Have you ever wondered why a soccer ball flies through the air when you kick it? Or how a roller coaster zooms upside down without falling apart? The answers lie in the fascinating world of physics, specifically the realm of motion and force. Hi learner! Welcome to Physics Courses. Today's topic is motion and force. Imagine yourself as a detective, about to unveil the secrets behind everything that moves, or doesn't. Get ready to explore pushes, pulls, and everything in between that makes our universe tick. This is your chance to become a master of motion. Are you ready? Interaction between two objects that causes a change in the motion of the objects. This is force. What impact can forces have on objects? Make it move. Make it speed up. Make it slow down. Stop it. Cause it to change direction. Cause it to change shape. In what way does the mass of an object impact force? Let's find out. Rishi Kanada, a great Indian scientist and philosopher, had given Vaisheshika Sutra in 600 BCE, which describes the relation between force and motion. Today, his three laws of motion are instrumental in describing the movement of any object in the universe. Isaac Newton, a renowned physicist and mathematician from England who adapted it in his book Philosophica Naturalis Principia Mathematica, 1687, the correlation between force and motion. Kanada's first Sutra of Motion. Vegaha Nimitta Visheshat Karmano J8. Translation: change of motion is due to impressed force. The law states that an object at rest tends to stay at rest and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Newton's first law of motion states an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in motion at the same speed and in the same direction unless acted on by an unbalanced force. Kanada's second Sutra of Motion. Vegaha Nimitta Pekshat Karmano J8 Nyaktik Kriya Prabandha Hichu. Translation: change of motion is proportional to the impressed force and is in the direction of the force. Newton's second law of motion states the acceleration of an object by a force is inversely proportional to the mass of the object and directly proportional to the force. Kanada's third Sutra of Motion. Vega Sunyog Vishesh Virodi. Translation: action and reaction are equal and opposite. Newton's third law of motion states for every action, there is an equal but opposite reaction. Try these questions. Let us now understand another connected subtopic called momentum. The measure of an object's resistance to changes in its state of motion due to the application of a force. Momentum equals mass in motion. Momentum equals mass velocity. P equals mv. Conservation of momentum. A scientific principle that states that the total momentum of a system or group of objects remains constant if no external forces act upon it. This principle applies to objects in motion. It is closely related to Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. M1v1 plus M2v2 equals M1 plus M2v. Conservation of momentum in one direction. When two objects interact in a single direction, the total momentum of the two objects before the interaction is equal to the total momentum after the interaction. Conservation of momentum in two directions. If two objects interact in two perpendicular directions, the total momentum of the two objects before the interaction is the same as the total momentum after the interaction in both directions. Now let us understand terms like impulse, When a force is applied to an object, it will result in a change of momentum. This change may involve a shift in velocity, such as an increase or decrease in speed, or a change in direction. An impulse causes a momentum change. Impulse equals momentum change. F increment t equals m increment v. Further, let us check what is meant by inertia. The tendency of an object to resist a change in motion. This means that an object will either stay at rest or continue moving in a straight line at a constant speed. Also understand acceleration. The change in the speed or direction of an object's movement. Acceleration equals change in velocity/time. Now, differences between contact and non-contact forces. Contact force requires two objects to be in physical contact with one another. Typically caused by physical objects, such as when two objects rub against one another. Typically localized and affects only the two objects that are in contact. Non-contact force acts upon objects without physical contact. Typically caused by energy, such as light, sound, and magnetism. Can affect multiple objects at once. Here's an activity to sort the forces. Let's meet in next topic. Happy learning!